When you finally unbox a top-of-the-line AI workstation and set that brutalist chassis on your desk, the temptation is to immediately test its speed. The conventional playbook says you plug it in, install the CUDA toolkit, download a popular model like Llama, and immediately run benchmarks to check your tokens per second metrics. If you are a solo developer working on a single machine, prioritizing those benchmarks on day one misses the bigger picture. Treating a personal AI rig like a distributed cluster server ignores your actual limitations. Without a system that lets you work alongside the machine, this hardware usually ends up as a highly expensive paperweight. For a single developer working at the edge, attention and feedback loops determine the pace of progress more than raw GPU count. You already have the power. You need the time to use it. This pyramid structure represents the access layer, a 5-part interaction stack sitting beneath the actual AI models at the very top. As the tiers pulse together into a unified system, the machine moves from a passive server to an active participant in your lab. Let's look at this split screen comparing a traditional SSH terminal on the left with a high-fidelity desktop environment on the right. For the reach tier, standard SSH falls short. AI workloads require full desktop control to monitor long-running training jobs without scrolling through raw text locks. Game streaming software provides this visual access with near-zero latency. This establishes a remote-first mandate. Your primary laptop becomes a thin client, meaning you never have to physically walk over to the workstation. Moving to the Collaborate tier, watch as the AI agent node drops directly into the machine's local storage. Most developers keep the AI coding agent on their laptop and send commands over a network. Installing the agent on the rig itself eliminates network hops. The AI can modify local files or access the underlying Docker engine with zero latency between decision and action. If you want to see more breakdowns of edge AI architecture and workflows like this, take a second to hit subscribe. These first two layers solve the attention bottleneck by putting the AI assistant inside the machine, rather than forcing you to marshal commands over a distant connection. Next is the Explore layer. If you tell an AI agent to look up information, basic tools only let it read static text. But that fails when an agent needs to navigate dynamic, authenticated dashboards, as shown in this stylized representation of an agent actively driving a complex web browser. By supplying the AI with a headless browser integration, it gains the ability to autonomously navigate pages and capture perfectly cropped screenshots from the web. Warning tone. This leads to the Automate tier, which carries significant risk. Letting an autonomous agent execute raw shell commands directly on your host machine can lead to a catastrophic deletion of critical files. This diagram illustrates the solution: NemoPla sandboxes. These are secure, isolated environments, represented by this transparent box, where the AI operates with a strict resource budget. Harmful commands bounce harmlessly off the walls, cut off from your operating system. Implementing this strict sandboxing layer is the threshold that moves AI from providing theoretical coding help to performing safe, unattended automation in the real world. The final layer of the stack is publishing. This step shifts focus away from technical execution and toward generating long-term value from your daily sessions. This flowchart maps the custom AI skill process. The AI reads your session's terminal text, grabs relevant screenshots, and outputs a drafted article. To do this safely, an automated privacy scrub scans the draft, deleting personal IPs or API keys before issuing an approval checkmark. Automating this pipeline ensures every experiment leaves a trail. It turns solo work into a series of public artifacts that others can find and cite, letting your learning compound into a reputation. Let's look at what this enables in practice. Imagine sitting next to a steaming flat white coffee at a local cafe, working on a thin laptop while your massive workstation stays quietly at home. You open your interface and give the AI a single command: write up an article on yesterday's configuration session. You don't touch a terminal interface or type a line of code. Instantly, the agent reads the logs, drives the browser for fresh visuals, drafts the post in your voice, runs the privacy scrub, and commits it to your repository. This invisible infrastructure makes commanding a supercomputer from a coffee shop a daily reality. The raw speed of your GPU is only useful if your interaction workflow allows you to ship. The AI models that everyone benchmarks on day one are fungible. In 6 months, they will be obsolete, and you will simply swap them out for something better. Compare that to the base configuration in this diagram. Your custom interaction stack is a solid foundation. Changing how you securely automate agents is difficult, so it pays to get it right while the colorful model blocks are swapped in and out on top. Now that this automated machine is prepared and protected, we can finally look at testing our first actual inference model on it. Raw compute handles the processing. The access layer provides the partnership required to actually build something with it.